screen share kurchi today, but for next class we'll use this board. Today is another the introductory class, another one. And can you see the screen?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So these are the introduction of these books. The first part of the book is physical design. So in the physical design, there are several components of those. The introduction of the physical design is here. You will get some flavor of these topics in here in this lectures today. The name is you already know that electronic design automation, or EDA. This is actually I already mentioned yesterday that for smaller circuits, very simple circuits, it is possible to design manually, but for a little bit bigger circuits and also the most applicable application specific circuits, those are very big and cannot be designed manually, and we need so electronic automation system. So in that case, there are some softwares, and also there are some machine, right? Automatic machines are also there, and so altogether, actually, this system is known as electronic design automation. And in here we'll see some VLSI design flow, how this starts from the scratch and going to the final products, and VLSI design style, the layout layers, and design rules. You already know this, but we'll review a little bit here. Then the physical design optimizations and some algorithms and complexity. And here you see the graph theory. You already know one graph theory, right? I already explained. The graph theory is a Euler's graph that we used. So there are more graphs are also here, and then common electronic design automation terminology. So let's see here. So, but these are very basics. The Moore's law in 1965, and how is growing here. And we already know that in every 18 months, it says the silicon, the transistor size will be half. And there are some the historical things we don't like to close in here. This one is important for you. You see the system, how the VLSI design starts from system specification, right? System specification means whatever, let's say you want to design, for example, you want to design a full adder circuits. So in that case, you have to specify what you need, what will be the input and what will be the output, how many inputs, how many outputs. Right? Those are called system specification. Right? For example, a full adder circuit, right? A full adder circuit, so you need a block, and then there will be one, let's say it's a 1-bit full adder, you need a input, one input, and no, two input, and then will be one output. Right? This is the standard, but it's actually not true. There is some in some complicated adder circuit, you need a two output because there will be some carry, and also if you use the same full adder in the first place, then you have only two inputs. But if you put it into the intermediate space, right, then there will be some another extra input, right? This input will be coming from the carry from the previous block, right? So this is the complete specification of a full adder, right? So that is called a system specification, right? So these are the things you need to know from this system specification. And then you go to the architectural design. So this is the block diagram, right? This is a full adder. And now when you go to the architectural design, then you need to go what is inside. What is inside the full adder, right? We already know that there will be two what's called XOR gate, and one OR gate and one AND gate. So you have to go inside this block, and we'll get all of this inside this called architecture, right? Inside of those, and then what is a functional design? So when you go to in more deep, then what is inside the XOR gate? You have to, inside the XOR gate, you will see there are like a one and no, what's called one AND gate, no, two AND gate, right? And there is A bar B, and then A B bar, and there is a one OR gate also there, right? Inside the XOR gate, right? Inside XOR, right? Inside the XOR gate, there are two XOR, but one XOR is actually inside. There is a two AND gate, right? A bar B and A bar and A B bar, right? XOR গেটের ভিতরে কি আছে? A bar B আছে আবার A B bar আছে, right? A B bar. So that means this is the main function. So you have to go the functional design for XOR gate. And also there are some A invert, so that means there are inverting signals. So that means there are two inverters and two AND gate and one OR gate. Those are the functions for XOR gate, right? And there is a AND gate also there, and then there is a two input OR gate there. So those are the functional design, right? Those are the functions. And now we'll go then down to the circuit design. So now we have to go like how to get those A and B, right? You know that A and B by using a CMOS diagram, right? You already done, already designed, right? By using, there will be A bar A bar B. That means this is an AND gate. That AND gate will be designed by using uh, maybe six transistors, right? There will be, first you have to design a NAND gate, and that NAND gate will consume will require actually four transistors, right? Two PMOS and two NMOS, because these two inputs, so there will be two PMOS and two NMOS. You make like an four input, right? Four transistor, right? Four transistor NAND gate. Four transistor দিয়ে NAND gate একটা তৈরি করবে ফার্স্টে, and then you need another two transistors NOT gate, so then make the AND gate, and there will be another AND gate here, and then inside there is a two input OR gate. Yes, OR gate also, you need a two input NOR gate first, two input NOR, and then you have to put OR NOT gate at the end and make it OR gate. And those are the real circuit diagram and the real circuit design. And that is actually CMOS design, right? You have designed a CMOS diagram by using those number of transistors, and then what you do, you put those transistors, those CMOS diagrams into layout. Yes, the layout design will be done by, you can do by using any software, and that will be you can do Cadence or Microwind, and that will be the circuit design diagram, right? The CMOS diagram and the layout, the together is known as a circuit diagram. And in here you can see in the two parts here, and this actually right, this is a circuit diagram in here. So when you have a layout like this, right, you have a layout design. Now you have designed also all of this like a DRC, right? You can do check here. You have done already. So those are the circuit design, right? To make sure that your circuit works fine, and then it comes the physical design, right? তোমার এই পর্যন্ত তুমি করেছো, right? Up to that point, right? Up to this point, you have already done the upper part. And now we have to do the physical design here, right? In these topics, this course, not course actually, this part of the course, right? Maybe in the first half or 7 weeks of the semesters, we will be using, we'll be concentrating on the physical design components. So and then we'll go to the next part is a physical verification and fabrication, packaging, testing. Those are the things. So now if you look here, so what we do now in physical design, the physical design has several components, you see here. The first part is partition, then chip planning, placement, then clock tree synthesis, signal routing, and timing enclosure. So you see there are 6 topics. And the 6 topics will be covered in physical design parts. So now, if you look at here, the partitioning. What is partitioning? Partitioning in C here in the right side. Here you already you can see here all of those 1, 2, 3, 4, 5, 6. Right? There are 6 modules of these topics, and the first module is partitioning. And partition, you can see here the partition here. You can this is the whole things, whole circuits. This circuit is actually copying from this side in the left side, and in here is showing only the what's called block diagram or the circuit symbolic diagram, right? Not the layout. But you can see or show also the layout, but the layout is hard to identify that what is the layout, because when you make a layout, you cannot tell that this is an AND gate, or this is an OR gate, or this is an inverter, right? It is hard to identify from the layout. এজন্য এটা we can see only on the symbolic diagram, right? Let's say in this symbol, right, on the left side, এখান থেকে আমরা right side নিয়ে আসছি this one, right? So from here we can easily identify the partition. And in here, you see here, there is how many blocks, how many circuits blocks are there? Logic blocks. You see here is one inverter. There is a two inverter. You see another inverter in the bottom, or you can see here there's a two inverter and two OR gate, and one AND gate. Right? No, two AND gate. There are two AND gate, two inverter, and two OR gate. So there are total six logic circuits are here. So this now let's say this is a circuit you want to design by a group, right? That is called partitioning. Let's say there are four people in a group, and you are asked to design the one part of those partition. Let's say here the first partition is a one inverter and an AND gate, and the second partition is only one inverter. Third partition, let's say here is only one OR gate, and the fourth one is a NAND gate. No, AND gate and an OR gate, the fourth partition. But how do you know this will be the partition? This is the right one, right? We don't know this is the efficient one or the worst one, right? We don't know. So that's the thing we have to decide, right? There is some partitioning algorithm, so we have to apply those algorithm, and can apply these circuits, and we'll find out which one will be in one group. You see, there are some partition have only one logic circuits, and some have two, and so we don't know. And also there is some partition in the top left, some in the top right, and one in the top left in the bottom and right bottom, but we don't know this is the right. Maybe these things, this inverter, the top I think bottom left one will be the top left, and the top left will be in the top right, right? We don't know, right? At this point we don't know anything, whether which one will be more efficient. So we need to find out, and we need to learn the algorithm for making the efficient placement, right? So we learn next class at least one algorithm, and we'll see that's how to divide these circuits. And also you see we are divided into 4 partition here, and we don't know, right? Why do you put it into inverter and an AND gate in the top left? Why did not you put only no, especially for the bottom diagram, you see that only the one inverter in the top, no, in the left bottom. But we can put the AND gate also with the inverter and make it inverter and an AND gate in the bottom left in here, right? আমরা এখানে এখানে করতে পারতাম, এই পার্টটা একটা পার্টে করতে পারতাম, and bottom right এ শুধু OR gate রাখতে পারতাম, but we don't know why did we make it, right? So we have to find that, and that is called partitioning. And then when you get a partition, and then we'll make a layout, right? আমরা পার্টিশন করার পরে তারপর আমরা ইন্ডিভিজুয়াল স্টুডেন্টসকে দিয়ে দেবো যে you do it for your layout, right? For his group. And then after getting the layout, right, once you make the layout, then you know the area, right? When we have this kind of diagram, right, this is symbolic. You don't know how much will be the size, right? You have no idea, right? Whether it will be rectangular size or be square size, you have no idea. That's why you have to wait and see once you have done your layout. Now you see you have a layout. Once you have the layout, now you know which one will be placed where, right? You see that this one is too big. The top, you see that this one is this rectangle is very big, and you have to put it in the top right. And the left one you see, and this one is this one also rectangle, but we are placed in the rotate. After rotating this one, we are placed in the vertical position, and instead of putting into this way, right, putting into this way, from left to right, a rectangular size, but we rotate this one in 90 degree and make it the vertical, right? We make it like this way, because otherwise there will be maybe some loss, will be there will be some loss of silicon, there will be some vacant space, right? So that's why we need to make a layout, right? And you have already done, the layout, right? আমরা ওটা এরিয়া ক্যালকুলেট করেছি, রাইট? পরীক্ষায় এসেছিল, লেআউট করার পরে তোমাকে দেখতে হবে এস্টিমেটেড এরিয়া। তোমার এরিয়া দেখার পরে তুমি বুঝবে যে এটা স্কোয়ার শেপ আর রেক্ট্যাঙ্গুলার শেপ, রাইট? এন্ড হাউ মাচ ইজ দ্যাট, রাইট? তুমি যখন এটা জানবে হাউ মাচ ইজ দ্যাট, দেন ইউ ক্যান প্লেস, রাইট? বাট স্টিল এখানে যদি এরকম if you have only 4 pieces, then maybe you can place manually. You can place how much is the length and width and where should I place, right? এই দুটো উপরে প্লেস করবে না এটা নিচে প্লেস করবে, it should be vertically or it should be horizontally, you don't know, right? So এটা প্লেস করতে হবে based on those. তাহলে তোমাকে এটা আগে এটা this is for small numbers like 2-3 pieces, 4 pieces, 5 pieces, maximum 10 pieces you can make it manually. But when you have like 100 pieces of layout, right, when you will be working for like a Ulka Semi or some neural semiconductor or maybe some big companies, right? There are hundreds of blocks, big blocks, right? And you cannot do it manually. So what you need to do, you need to know some algorithm. So the algorithm will place, right? The algorithm will run, and you have to write a code, and you have to write a program. The program will write a program, and you have to put the data set, right? The length and width of each of the block, right? প্রতিটা ব্লকের লেন্থ আর উইডথটা তোমাকে ইনপুট দিতে হবে প্রোগ্রামিং এর ভিতরে, and then they will run a simulation program and script, then they will right, there will be loop equation, loop programming, and they will right, within a seconds, they will find out the block number, where would be the block number 1, block number 2, block number 3, and where should we place, right? They will give us, and then it will be automatically placed, right, by the software. But when we know the coordinates of those, right, block number was the serial number, and where should we place, or the coordinates. Coordinates means the bottom, like when you have a block like this one, so the coordinate, starting coordinates will be the coordinate, like this one will be the coordinates, right? This will be the coordinate. The bottom left will be the coordinate, and this one the coordinate will be bottom left, right? So bottom left, if you know the coordinates of those blocks, so you can easily place those all the blocks. Okay. Now that is a chip planning. but the placement, you see, এখানে place করার পরে is not is a planning, right? So after planning that this one will be there, all those will be there, it's okay. Now you have to place, right? You have to place not only the layout, right? তুমি layout করেছো এতক্ষণ ধরে, তুমি layout, we have placed the layout here, right? The chip planning এর ভিতরে তুমি layout place করেছো, but that is not the end, right? So the layout is not the only components in the IC, right? You have to put those, you see, in this place, this is a planning, in here, all the layouts area are placed side by side, and there is no more space between those, right? কোনটার ভিতরে দেখো কোনো গ্যাপ নাই, but that is not the right place, right? এটা হলো just plan করেছে, but is not the right placement. Placement means place the layout and also keep some space between the layouts in order to place the channel, right? Not place the channel, actually keep some channel in order to draw the metallic line, the connecting line, and you must need to keep this. You see, there is a space between these two, because we need to route, you need to put some metallic wire here to connect from one block to the another block. You see that the original circuit has some connection. You see, the output of the inverter is going to the input of this AND gate, and another input from of the AND gate is coming from the primary, another input, right? So you have to make sure that we must need to keep some space for making those metallic line. These are the metallic line will be connect from one input, maybe from primary input to the circuit block input, or maybe the output from one gate will go to the input of the another gate, right? So there must be some metallic line, right? Wire থাকবে, wire কোথায় place করবে, কোন পথ দিয়ে the wire will flow, right? And maybe there will be some wire will go through this place, or somewhere will go straight down, or maybe here and go to this side, right? You see here in the bottom one. So that is called placement. That means you have to place the layout by keeping some space between those, and also keeping some space around those, because around there will be some pin. You see, these are the pins. You see this one, the black one, two, three. These are the pin, right? And the pin will be connected to the output of the IC, and also this pin will be connecting to the input layout, right? This pin will not be floating, of course, right? This pin will be connecting. Maybe if this is an input pin, this input pin will be connecting to the here, and we'll apply the input signal from the outside, and put it in here in this pin, right? So those are called placement. And then after you place, then you need a synthesis, right? Placement করার পরে, then you have to make sure that those all the signals you see here, there's a ground line here, and then there will be some power line there, right? You have to apply some power line and then ground connection, so BDD and VSS, and then apply some signal and see after synthesis that if the signal is flowing, or you can get the real output or not, right? You have to make a synthesis and see if the circuit or the layout, if this all are working, right? But remember that everything is still in the simulation mode, right? যদিও এটার নাম বলেছে physical design, but actually all are in software mode. এখনো কিন্তু কোনোটাই তৈরি হয় নাই, right? এগুলি কোনো কিছুই কিন্তু এখনো হার্ডওয়্যার না, সব কিন্তু সফটওয়্যার মোডে. Everything is in the software, all are in simulation. right? So like clock 3 clock, you have to apply the clock, input clock, and see how this signal is flowing, and how the output is coming out, and compare the fault free, compare the real signal, like তোমার ট্রুথ টেবিল থাকবে, ট্রুথ টেবিলের সাথে কম্পেয়ার করতে হবে if this is all right, and uh, then signal routing. তারপরে এখন দেখো যে তুমি এখানে দিয়েছো যে এই সিগন্যাল যেভাবে কানেকশন দিয়েছিলে those are appropriate or not. Now you have to apply some other techniques and see তুমি যে পথ দিয়ে সিগন্যাল রাউটিং করেছো is that efficient, right? তোমার সিগন্যালটা কি টাইমলি, না তোমার কি বলে যে যে পথ দিয়ে তুমি সিগন্যালটা রাউটিং করেছো, that means the metallic wire, you place the metallic wire in throughout throughout the channel, and there are channel, right? In the channel chilo, there are some channel, and then you routed in this place and then checked and it was all right. But now we need to now you need to check if this routing is efficient, right? If this routing channel is good, or if the length of the wire is enough, or we can make is minimum wire length, আমরা এটাকে ওয়্যার লেন্থটাকে মিনিমাইজ করতে পারি কিনা, রাইট? যে পথ দিয়ে আমরা লাইন টেনেছিলাম এখানে, was that efficient? If it is not, then we have to apply some other algorithm to make sure that the wires length of the wires are minimum and the connections are okay, right? All the output signal must be the same, input signal must be the same as the real truth table, must match, but keeping those same, we need to make sure that the length of the wire is minimum, right? তারপরে এটা finish হয়ে, that is signal routing, and then finally what we'll do, we'll see the timing and closure, right? আমরা হয়তো মিনিমাম ওয়্যার তৈরি করতে গিয়ে যদি আমরা এমন করে ফেলি যে ওয়্যার লেন্থটা বেশি ছোট হয়ে গেল, আবার কোনোটা ওয়্যার লেন্থটা বেশি বড় হয়ে গেল, রাইট? দেওয়ার পরে তারপর আমাদের আবার টাইম চেক করতে হবে। নাও if all the signals are properly propagating to the next signal, no next circuit, নেক্সট প্রথম সার্কিট থেকে যেটা সিগন্যাল আউটপুট হবে সেটা যেন রাইট টাইমে নেক্সট সার্কিটে রিচ করতে পারে, রাইট? ইফ দ্য সিগন্যাল ইজ ডিলেড, then there will be problem, and there will be slow, or maybe মনে করো যে তুমি একটা সিগন্যাল, একটা ইনপুট, এখানে তোমার তিনটা ইনপুট আসবে, right? And this 3 input will be coming from 3 different circuit. Let's say এখান থেকে আসবে একটা, এখান থেকে আসবে একটা, আর let's say এখানে আরেকটা সিগন্যাল আছে, রাইট? এখান থেকে আরেকটা, রাইট? তাহলে 3 ব্লক, তাহলে এই ব্লক দেখো এখানে 1 যদি দিই, এখানে 2, এটা 3, তাহলে ব্লক 1 থেকে যদি সিগন্যাল আসে এটা বেশি টাইম লাগবে, because the time delay, because the long path needs to, right, coming to the long path. But the signal coming from 3 will be faster, 2 will be the medium, right? Let's say এখানে মনে করে 3 থেকে এটা সিগন্যালটা আসলো, এটা 1 সেকেন্ডে 1 ন্যানোসেকেন্ড, এটা না মনে করে এটা ধরো আমরা বললাম 5 ন্যানোসেকেন্ড, এটা এটা হলো 6 ন্যানোসেকেন্ড, 6, আর এটা মনে করো 10 ন্যানোসেকেন্ড, হ্যাঁ? 3 নাম্বার 1 ব্লক থেকে যে সিগন্যাল আসবে সেটা 10 ন্যানোসেকেন্ড টাইম লাগবে এখানে আসতে। তাহলে এইটা যে ব্লক নাম্বার 4, এই ব্লকটা যদি অপারেট করতে হয়, তো দিস ওয়ান উইল অপারেট at 11 ন্যানোসেকেন্ড at least। 10 ন্যানোসেকেন্ড পরে যদি এই সিগন্যাল 1 না ব্লক 1 থেকে সিগন্যাল আসতে লাগবে 10 ন্যানোসেকেন্ড। এখন তুমি যদি এই নাম্বার 4 ব্লক, এই 4 নাম্বার ব্লকটা যদি তুমি 7 ন্যানোসেকেন্ড পরে যদি তুমি অপারেট করো, তাহলে তুমি ব্লক নাম্বার 1 এর সিগন্যাল কিন্তু এখানে পাবে না, সেটা আগে যে সিগন্যাল ছিল সেই সিগন্যাল 0 বা 1 যাই থাকুক সেই ভ্যালু নিয়ে এটা রান করবে। সো দ্যাট ইজ ডেঞ্জারাস। তাহলে কি করতে হবে, এই যে 1 থেকে যে 1 ব্লক থেকে যেটা আসলো, উই হ্যাভ টু ট্রাই টু মেক দিস ওয়্যার লেন্থ মিনিমাম। এটা যদি মিনিমাম করা না যায় তাহলে এটা রেজিস্ট্যান্স কমাতে হবে, এটার ওয়্যারের থিকনেস বাড়াতে হবে, তাহলে এই সিগন্যালটার প্রোপাগেশন টাইম কমে যাবে। সো দিস উইল মেক ইট ফাস্টার, so that instead of 10 maybe in that case it will reach at maybe 7 nanosecond. তাহলে আমাদেরকে এইভাবে ডিজাইন করতে হবে যে কোন ওয়্যারটা কিরকম সাইজ। তোমরা ভিএলএসআই তে করেছো সবগুলি 4 ল্যামডা দিয়ে করে আসছো, বাট যখন তুমি রিয়েল করবে তখন তোমাকে দেখতে হবে যে এটা কি করতে হবে। তুমি যদি এখন এটা বড় করে ফেলো তাহলে তোমাকে এইখানে যে লাইনটা যাবে যে পথ দিয়ে, সেই চ্যানেলের জায়গাটা বেশি লাগবে, ওয়্যার, বিকজ ওয়্যার ইজ টু ফ্যাট। তখন তোমাকে আবার এই দেখো এই যে উপরে ছিল তুমি কতটুকু জায়গা রেখেছিলে এখানে, রাইট, ইন দিস কেস, সো দ্যাট উইল শুড বি কনসিডার্ড হিয়ার। তারপরে আবার আছে যে তুমি যদি এটা যদি তুমি বড় না করতে পারো, দেন হোয়াট ইউ নিড টু ডু, you have to delay the signal of 2 and 3. 2 নম্বর এবং 3 নম্বর ব্লক থেকে যে সিগন্যাল যাবে তাকে তোমাকে ডিলে করতে হবে। ডিলে করতে গেলে কি করতে হয়, তোমাকে বাফার দিতে হয়, এখানে সাম বাফার অ্যাড করে তোমাকে ওইটাকে ডিলে করাতে হবে, যাতে সিগন্যাল না ব্লক নাম্বার 1 এর সিগন্যাল যতক্ষণ পর্যন্ত না আসে ততক্ষণ সিগন্যাল 2 আর 3 ব্লক থেকে ওখানে ওয়েট করে। না বাফার দিলে কি হবে, ওখানে ওয়েট করতে থাকবে, right? So these are the some of the techniques and we have to analyze during the timing closure. Okay, so this is এটাই এই টপিকস এর ভিতরে ফিজিক্যাল ডিজাইন আমরা পড়বো। ফার্স্টে আমরা বিভিন্ন অ্যালগরিদম দেখবো, এই সবগুলির জন্য অ্যালগরিদম আছে, আমরা দেখবো সবগুলি, and then we'll see, will run, right, তোমাদের ল্যাবে এটাকে রান করাবে। this will actually the most important and call it PNR বলে, PNR এটাকে n বলে যদিও, is place and routing, place, placement and routing, and এর শুধু এ না নিয়ে, এ আসলে ভালো দেখে না এই জন্য এন দিয়েছে, and এর এনটার উপরে জোর বেশি আসে এই জন্য PNR, প্লেস এন্ড রাউটিং। তো এই চ্যাপ্টারে এই বইতে আমরা পুরোটা প্লেস এন্ড রাউটিংটা পড়বো, এবং প্লেস এন্ড রাউটিং এর এইগুলি সবগুলি হলো, দেয়ার আর 6 টপিকস। আমাদের বইতে আসলে 8টা টপিকস আছে, আমরা দুইটাই, এই যে প্রথম চ্যাপ্টার তো লাগবে না, আর মাঝে আর একটা টপিকস আছে ওটা আমরা না পড়েও, আর পুরোটা টপিকস আমরা পুরো বইয়ের অনেকগুলি অ্যালগরিদম আছে, আমরা সবগুলি অ্যালগরিদম যদি দেখতে চাই তাহলে এই বইটা আসলে পুরো সেমিস্টারের জন্য, পুরো মানে 14 উইকস এর জন্য। কিন্তু আমরা যেহেতু আবার টেস্টিং এর জিনিস পড়তে চাই, এই জন্য আমরা অ্যালগরিদম গুলি সবগুলি অ্যালগরিদম পড়বো না, আমরা যে অ্যালগরিদম গুলি বা যে টপিকস গুলি আমাদের বেশি লাগবে, আমাদের বেশি ইম্পর্টেন্ট বা জেনারেল ইউজ করা হয়, মোর পপুলার, সেগুলি আমরা পড়ে যাব। আর চ্যাপ্টারের প্রত্যেক চ্যাপ্টারের কিছু কিছু জিনিস আমরা বাকি রেখে যেতে হবে, না হলে আমরা সময় পাবো না ওই টেস্টিং পড়ানোর। Right, so this is all for the class. Now তুমি বলো any question? আমি মিটিং এর রেকর্ডিংটা স্টপ করে দিই, রেকর্ডিং স্টপ, no, রেকর্ডিং স্টপ, স্টপ করবো কোথায়, স্টপ স্টপ শেয়ারিং, এখানে স্টপ, go here, stop recording.